What's going on, everybody? Welcome to another video, and in this video we're going to get our hands dirty and try to do some actual programming, right? In this example video I'm going to talk to you guys about how to generate your Fibonacci series over here. Alright, let's get started. Most of you might know what a Fibonacci series is. For those who are not aware or just learned it a long time ago and forgot about it, let me give you a quick recap. A Fibonacci series is a series of numbers wherein each number is the sum of the previous two terms except for the first and second term. The classically in the Fibonacci series starts with two ones and every other value is sum of the previous two terms. So here the first two terms are 1 and 1 by default, and the third term which is actually can be calculated by adding these two terms. So this one is 2, and after the next term is the sum of the next two terms, so which is 2 and 1, which is 3, and after that next term is actually sum of 3 and 2, which is 5, and you get the idea. And then afterwards you get 8, and you keep on going. In some implementations, right, you start with 0 and 1 and then you proceed further, and essentially since you have 0 over here, it's just a repeat of the same thing, so on and so forth. Right, we are going to start with this one over here, this implementation. I mean, because why the heck not? You can even try this. It's not a big deal once you get a hang of it. Alright, first things first, we have to tell the user, like, we have to ask the user how many terms he or she wants. See, if you look at this Fibonacci series, this is a never-ending series. It will keep going on and on and on. Right, so we need to tell the user, like, hey, you know what, I'm not going to print all of them, I'm just going to print only a particular number of terms of it, so you better tell me how many values should I go and print, right? Calculate as well, right? So for that we need an input. So input from user, and the input is actually, let's call n, and we'll just say input, we'll just say enter the number of terms in the series. Alright, now here's a catch. This is a string input, right? So we want to make sure this is an integer for our purposes. So what you're going to do, I'm just going to call int and put it over here, wrap this around, and thereby it's only take integer values and we're avoiding any errors. Cool. Now let's proceed further. Now what we can do is create a list. Create a list called as fib list. Alright, and what is this fib list is nothing but an empty list, not an empty list per se. It's just going to be a list with values 1 and 1. That's all about it, right? And now what you can do is try to calculate the remaining terms of the Fibonacci series, because the first two terms are 1 and 1, or you can actually put a 0 and 1. Why the heck not? Not a big deal. And what you can do is we can write a for loop, right? And this for loop should start with index number 2, right? It should start with index number 2, and for that let me put an I in range, and the index should start with from 2, right? So I have to put 2, and note I am going up to n terms, let's say, so I need to give n plus 1, and then I'll put the increment of 1 over here. This way I'm just going to get I properly. So let me just check out I. If I were to enter 10, I'm going to get up to 10 terms over here, including 0 and 1 and all of that. So far so good. Now yeah, I might technically speaking, if I were to get 10 terms, I'm getting 11 terms over here. Like, you get the idea. If I want that case, I can just remove this plus 1 and all, but it's fine. But you got this part, right? So every time when you iterate, you get one particular value of I, and here is where the magic comes in. You can say new term equals fib of I. Okay, fib of I minus 1 plus fib of I minus 2. There you go. And then what we can do is just a fib dot append new term. There we go. Once we have this, we have our Fibonacci series. We have our Fibonacci series ready. The implementation is ready, right? And we can just say print, and then we say new, and then we say fib to get our terms. Okay, we can also print another line and saying that the Fibonacci series up to n terms is, and then we'll put an f at the front, and there we go. And now let's run this. Let's give the same input 10. There we go. The Fibonacci series up to 10 terms is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34 and 55. Wonderful. Now if you're like, hey, I don't like the 0, 1 starting, I want to be the classical person who wants to starts with 1 and 1, go ahead, no issue. All you have to do is make a minor correction over here and run this again, and it'll ask you for a value, and there you go. Cool, there you have it. Now this is one way of implementing Fibonacci series, and now there's another way I want to talk to you guys about the implementation part of it, right? And this is going to be a lot more fancier version. So this is like, I'm going to call it Fib1, and I'm going to call it Fib1, Fib1, Fib1 and Fib1, and there's another way to implement it too. So this is called method 1, and this is like make a list and use loops in a classical style. This is what we did in a classical style. If you were to approach any compiled programming languages, you will run a for loop and you'll use this algorithmic approach like this. Python can make it a bit better. So I'm going to use now method 2. Method 2 is going to be Pythonic. And what do I mean by this? Just watch. First, what I'm going to do, I'm going to set up the values of A, two values A and B, these two to be my values, and then I'm going to create a new array. Fib is equal to A comma B, and this is Fib2, and then the same for loop, and the only difference is that I'm going to say A comma B equals B comma A plus B. There you go. And then I'm just going to append, okay, this is Fib2, and here I'm just going to append A. That's that. And I'm going to copy these two lines and paste it at the bottom, and I'm going to call it Fib2. And if I were to run this little fellow, right, I'm going to press 10, and it works out just fine. And I think I started in both the cases with 1 and 1, I mean 0 and 1, so I'm just going to put 0 and 1 in both the cases for comparison, and giving it the same value 10. And what do I get? Oh, I got another one. All right. But you see the point here, right? It's coming pretty close. Okay, what if I just append B over here? I think this should be working out fine. I think I made a mess up with it. There you go. I should have appended B. I get a bit confused over here. Anyway, now you might be asking, what on earth is happening here, right? I totally understand your confusion here, so let me walk you guys through. So when we created these two variables A and B and I put them in a list, this is pretty much similar to, writing 0 and 1 in the list and then appending terms over here, right? But here's the thing. When I say A comma B equals B comma A plus B, what will happen is that the original initial values of A and B will be used over here, and you'll get two values, and those two updated values will go over here. So the original value of B will go to A, right? The original value of A and the original value of B will be added, and that value will go to B now. So what you're doing indirectly here is that you are actually appending and simultaneously swapping the values to the new variables. So using the old variable values and then doing a little bit of tweaks with it, and passing them with new values using the old values, right? Now this is pretty much the same implementation of Fibonacci series, but in a more twisted way. In a more twisted way, Now that's why it happened like this. And once you did this, the new term in the Fibonacci series is actually B. I'm appending to this method list fib method. That's about it. And if I run it, I'm getting the same result over here. And if you were to ask me, like, if I were to put this to 1 and 1, will I get a different answer? Well, probably not. You're going to get the same answer as well. Even if I were to put up to, let's say, 15 entries and all of that, you're going to get the same answer. And there's a reason why I'm not going more than 15, because you look at it, up to 10 terms or something, approximately 10 or 9 terms or something, the values are very small, and suddenly over just a span of 3 more entries, you got a massive shoot of values like this. So if I were to go and run this piece of code and go for something like 25 entries or something, this will just go out of the chart and it'll go way higher. It's already crossing 100,000, 121,000 over here within with the 25 terms and all of that, right? Fibonacci series is notorious for expanding too big like that. And there you go. And this way you have implemented Fibonacci series in 2 ways. One, by using a simple classical iteration method. Another one by using Pythonic methods, wherein you are swapping and unpacking values and all of that. This is sometimes called as swap and unpack, because here first you're not only swapping the old values with new updated values, you're also unpacking them like this. So there you go. This is another way of implementing, right? Now what we're going to do is, like, in the next program, we'll run another example. We'll try to do the factorial of a factorial of a number, and we'll look at a little more in depth into that in that program. And once that is done, we'll start working on functions. All right, so stay tuned for that.